Is this thing going to take forever? Waiting, waiting, waiting.
Are you starting a business? Do you need a logo? Design.com offers.
Hello, everybody. Rebecca here. It is 7/28/2025, and it is 3:03 p.m. Eastern Standard Time. I do have y'all looking at EMSC right now, and as you can see, there was a 6.5 earthquake in the Nicobar Islands region, India region. This earthquake is still being confirmed. However, I can give you some information on this earthquake, and we're going to go look at this earthquake on Google Earth here, and we will check it out, and I'll give you some information on this area. Please, 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 as you comment, please remember to hit the like button. Please remember to subscribe. Okay, so this is the area where this earthquake has hit. This is the Australian Sunda convergent boundary, and then you have Adira Point over here, which is in the Nicobar Island region. And this Nicobar Island sit on the edge, eastern edge of the Indian plate, near the boundary with Burma or Sunda microplate, which is part of the larger Eurasian plate system. This boundary is marked by the Sunda subduction zone, a major convergent plate boundary. The Indian plate is moving northeast and subducting beneath the Burma plate at a rate of 6 centimeters per year. This creates a deep ocean trench, or the Sunda Trench, that drives high levels of seismicity, including megathrust earthquakes. The subducting slab dips northeastward under the Andaman Nicobar segment. It's segmented and highly curved, which adds complexity and variation to earthquakes behaviors in the region. The Andaman Nicobar Islands are part of the classic island arc system resulting from subduction-related processes. Barren Island is India's only active volcano, and Narkodam Island are both part of this arc and evidence volcano activity over time. The entire region is composed of ophiolithic complexes, volcaniclastic sequences, and accredited sediments scraped off the downgoing plate. This area does have tsunami potential. The megathrust faults in the Sunda subduction zone are capable of generating submagnetic earthquakes like the 2004 Indian Ocean earthquake and tsunami, which was a 9.1 to 9.3 earthquake, which originated just west of Nicobar Islands. Shallow quakes greater than 6 near this zone, such as the one that we are looking at, can pose tsunami risks depending on vertical displacement of the seafloor. The local geology of this area is that the islands are made of sandstones, shales, limestones. These are overlain by tertiary deposits, which is Miocene and younger, and in some places, ophelites or deep sea sediments have been uplifted due to tectonic activity. The reason why earthquakes are frequent here is the subduction of the Indian plate, thrust faulting, accretionary wedge activity, and segmented plate boundaries. Seismic hazards are extremely high due to subduction, shallow thrust faulting. Earthquake magnitudes often exceeds M6 and capable of M8 and M9, like in 2004. Tsunami risk significant due to undersea faulting and vertical displacement. This area is a volcanic arc and accretionary prism and forearc basin. So that is the information that I can give you regarding this earthquake, which has just struck in the Andaman Islands here. Now we can also look over here and see that we have the Sumatra fault system transform boundary as well. So we're going to be taking a look at our bigger earthquakes today. And as you can see, I am going over here to the magnitude 5s only. So this was the last earthquake that just struck, and it happened 25 minutes ago. So I have put into Google Earth just our earthquakes that have occurred today. So I'll show you which ones they are, actually for yesterday and today. And these are the ones that have occurred yesterday and today. And we are going to go over these earthquakes. So let me get this for you. We have already put all of these into Google Earth. So we're going to start off with the 5.1 in the band of C. Well, actually, no, we're not. The 5.1 in the band of C, I have not been able to locate as much information as I wanted to locate for it. However, this earthquake has appeared toward an oceanic convergent boundary and closer to an oceanic convergent boundary. And this is also an oceanic convergent boundary here. And we can see that this is Wakatabi National Park. And this is a beautiful picture of that area. But if we look here, we can see it looks like some underwater seamounts within this area. So I would say that geologically, there is some volcanism, but most of the volcanism is over in this area. This is the arc. Okay, so we'll move on to our next earthquakes. Both of these occurring in the same place. 5.2 east of South Sandwich Islands. And I had said for us to watch out for over here in the South Sandwich Islands. So we can see that this one is heading out towards the mid-Atlantic. And this one here is within the same area. This area had this earthquake on July 27th of 2025 at 9:37 p.m. It was east of South Sandwich Islands in the Scotia Sea region, approximately 10 kilometers below sea surface. It was a 5.2 officially when reviewed by seismologists. This event occurred just hours before, on the current date of July 20th, 2025, and it is recent. Historic seismic data shows that earthquakes of magnitude 5.2 regularly occur in this region, averaging one such event every few months. May 2025 was a magnitude 5.2. July 2nd, 2025, there was a magnitude 5.2. February 20th, 2025, there was a magnitude 5.2. And April 13th, 2025, there was a magnitude 5.2. According to cumulative records, no earthquakes of magnitude 6 or greater have occurred near the South Sandwich Islands in the past decade. This region generally sees smaller quakes in the size of 4 to 5 range. Because of the extreme remoteness, far from the major landmasses or inhabited areas, no damage or casualties are associated with this event, and none are expected. The patterns of frequent 5-ish magnitude quakes here are typical of tectonic activity along the South Sandwich Trench, caused by subduction processes. This quake is not considered out of the ordinary for this region. The South Sandwich Islands region is one of the most geologically active areas in the southern Atlantic Ocean, characterized by subduction, volcanism, and frequent earthquakes. The South Sandwich Islands lie in the Scotia Sea southeast of South America. They sit on the South Sandwich microplate squeezed between the South American plate to the west and the Scotia plate to the north. The South American plate is being subducted eastward beneath the South Sandwich plate at the South Sandwich Trench. So let's take a look here. We can see that, whoops. And let me get this. This is the South American Scotia convergent boundary. Then when we come over here, we'll do this one. You can see that we have, this doesn't want to pop up for me. Please do. This is the American Antarctic transform boundary here. So, South American plate is being subducted eastward beneath the South Sandwich plate at the South Sandwich Trench. This subduction is responsible for, and excuse them for being outside and weed whacking and cutting grass right now. Isn't that sweet? This subduction is responsible for high seismic activity, active volcanism on the island, and creation of the South Sandwich volcanic arc. Let me take a minute and wait for these people to move. My goodness. The volcanic arc, the islands form a volcanic arc similar to Japan or the Aleutians. Okay, so they're built mostly as stratovolcanoes. Most of the islands are volcanically active. Examples: Mount Belinda, Montague Island, one of the most active volcanoes in the region, and Mount Michael, which is Saunders Island, known for persistent lava lake. So we can see these are the volcanoes over here. This is Montague right here. And the other one is Saunders, but I don't see Saunders. There's Saunders right there. So these are the two here, Montague and Saunders. The magma type in this area is andesite to basaltic magma, typical of subduction zone volcanism. Eruptions are explosive, but most go unobserved due to the remoteness. Frequent moderate earthquakes, M4 to M6, occur along the trench and beneath the arc. Depths range from shallow, less than 10 kilometers, to intermediate, which is more than 100 kilometers. Most earthquakes are related to subduction processes, not faulting and overriding plate. The oceanic crust here is relatively young and thin on the subducting side, volcanic and arc-related on the overriding side. Back arc spreading may occur in the East Scotia Sea, contributing to regional complexity. And the reason that it matters is no continents are involved, just ocean plates interacting. Pure volcanic inlet island arc formation from subduction-driven magma. One of the few places with regular earthquakes and eruptions, but minimal human impact due to its isolation. So, that is what we have for this area. And I think I lost my mouse. And now we will move on to Fox Islands, Aleutian Islands. This earthquake was a 5.3, occurring 7/27/2025. This is our area for this earthquake over here. And you can see we have Mukishin volcano. Mukishin volcano is a stratovolcano. So, a magnitude 5.4 occurred in the Fox Island region of the Aleutian Islands, Alaska. The Fox Islands lie along the active Aleutian subduction zone where the Pacific plate subducts beneath the North American plate, resulting in frequent seismic activity, often at intermediate depths between 40 and 100 kilometers. Earthquakes of magnitude 5 to 6 are relatively common here and are typically associated with slab, internal deformation, or interface thrusting. This earthquake was confirmed by USGS, EMSC, and it is listed by EMSC as a 5.3. It was confirmed by USGS as a 5.4. At 88 kilometers deep, this qualifies as an intermediate depth event. Those typically produce less surface shaking than shallow quakes of similar magnitude. The proximity to Dutch Harbor suggests that local communities may have felt mild shaking, though no serious damage or tsunami warning was reported. Magnitude 5 plus earthquakes in this region are not unusual and rarely cause significant impact due to the remote and sparsely populated nature of the area. The Fox Islands, located in the eastern Aleutian Islands of Alaska, sit within one of the world's most seismically and volcanically active zones, the Aleutian Arc, which is part of the Pacific Ring of Fire. Excuse me 1 minute, I gotta get some water. The Pacific plate is subducting beneath the North American plate along the Aleutian Trench at a rate of 7.5 centimeters per year. This subduction forms the Aleutian Arc and is responsible for both frequent earthquakes and active volcanism. The Fox Islands represent part of the Eastern Arc, where convergence is highly oblique, producing both compressional and strike-slip faulting. The islands are mostly volcanic in origin, consisting of andesitic, basalt, and dacite lava flows, volcaniclastic deposits, or ash, tephra, and pyroclastics. These deposits often rest atop older oceanic crust from the Pacific Plate. The subsurface geophysical studies suggest a thin continental crust beneath the arc. The basement consists largely of oceanic crustal materials overlain by arc-derived sediments. And there is volcanism in the Fox Islands. Those would be Mukushin Volcano, Akutan Volcano, and Shishalden and Westdahl, which is on Unimak Island. Akutan Volcano is on Akutan Island, and Mukushin Volcano is on Unalaska or Dutch Harbor. These are stratovolcanoes, and they are built by explosive eruptions of andesitic magma. The hazards from these volcanoes in this area would be ash clouds, which affect aviation, lahars and pyroclastic flows, and volcanic earthquakes. And volcanic earthquakes often precede eruptions. The Fox Islands are part of a megathrust fault system. Frequent moderate to strong earthquakes of magnitude 5.7. Earthquakes occur along the plate interface within the downgoing Pacific slab or intraslab, along crustal strike-slip faults. Some notable recent seismic swarms have been linked to volcano activity or magma movement, slow slip events on the megathrust interface, and fault adjustment within the subducting plate. The Fox Islands helps geologists to study volcanism, inland crust formation, and plate interface behavior. Their geology contributes to hazard monitoring for Alaska and helps refine models of subduction zone behavior with implications for tsunami and earthquake forecasting across the Pacific. So, this is our information that we have for this area. And if we look back again, we can see that we have the North American Pacific convergent boundary here. Let's see, do we have a picture? Yes, we have a picture. Not very close to land, but it's a picture. The next earthquake was a 5.1 in Iceland. It was actually listed as a 5.0. However, it's still listed as a 5.1 by EMSC. On July 27, 2025 at 2340 UTC time, a magnitude 5.0 occurred in Iceland approximately 226.8 kilometers east of Reykjavik. The earthquake had a depth of 10 centimeters and was felt in various regions including Huffin, Akureyri, Muspelbar, and Kopavogur. I'm hoping I got those right. The event is part of an ongoing seismic activity in Iceland, particularly on Reykjanes Peninsula, which has experienced increased earthquake and volcanic activity since late 2023. The region has been under close monitoring due to potential for volcanic eruptions and associated hazards. As of now, there have been no reports of significant damage or casualties associated with this earthquake. Authorities are continuing to monitor the situation there closely. The geology of Iceland and the earthquake areas they're located on a tectonic setting. Iceland sits right on the mid-Atlantic ridge. So you can see if I back out here, this is the mid-Atlantic ridge. Let me close this here. This is the Mid-Atlantic Ridge, which goes all the way down this way. And that's a major divergent tectonic plate boundary between North American plate and the Eurasian plate. This means that the plates are moving apart, causing the crust to thin and magma to rise, creating volcanic activity. The earthquakes near Iceland is close to Rick James Peninsula, which is a highly active volcanic and seismic region. The peninsula is part of the volcanic rift zone where the mid-Atlantic ridge rises above sea level. The area has numerous fissures, faults, and volcanic systems. It's characterized by transform faults and extensional tectonics due to the divergent plate boundary. Iceland's volcanic activity is driven by the interaction of the mid-Atlantic ridge and a mantle plume beneath the island. This hot spot enhances melting and magma supply, making Iceland one of the most volcanically active regions in the world. The Rick James Peninsula has experienced recent volcanic eruptions, including in 2023 and 2025, and I believe there was one in 2024 as well. And that's at the Sundhökkur volcanic system. Earthquakes here are typically related to tectonic movements along faults and fissures as the plates pull apart. Earthquake depths are usually shallow, less than 20 kilometers, because they occur within the brittle upper crust. Excuse me 1 minute. Go to the living room. Okay, sorry. Earthquakes of magnitude 5.0 and plus are common, but typically do not cause severe damage due to Iceland's relatively low population density and good building standards. The area is also rich in geothermal features such as hot springs and geysers due to the heat from the magma below. So let's check in with chat real quick. Hello, hello, welcome to the chat. Please remember to hit like, subscribe, and share the video. Much love. Okay, our next earthquakes are for today. There was a 5.0 in Hokkaido, Japan region. And we can see that this is sitting in between, let me get this up here for you guys, the North American Pacific convergent boundary. And then we come all the way over here and we have the oceanic convergent boundary here. And this earthquake was 56 kilometers deep. This magnitude 5.0 struck near Sapporo, Hokkaido, Japan on Monday, July 28, 2025 at 12:10 p.m. local time. The epicenter was located approximately 159 kilometers or 99 miles southeast of Sapporo. This earthquake was part of a series of seismic events in the region. Earlier in the day, a magnitude 5.3 earthquake occurred in the southern Tokachi region of Hokkaido. Additionally, a magnitude 5.4 earthquake was reported near Obihiro, Hokkaido, just minutes after the 5.0. Despite the moderate magnitudes, there have been no immediate reports of significant damage or injuries. The Japan Meteorological Agency has not issued any tsunami warnings following these events. However, residents in affected areas are advised to remain vigilant and prepared for potential aftershocks. Hokkaido lies near the convergence of several major tectonic plates, primarily the Pacific Plate, the North American Plate, and the Eurasian Plate. The Pacific Plate is subducting beneath the North American Plate along the Japan Trench east of Hokkaido. This subduction zone is a major source of seismic activity in the region. The Pacific Plate pushes under Japan's landmass, causing stress to build up in the Earth's crust. When the stress is released suddenly, it causes earthquakes. These can range from moderate to very large megathrust earthquakes. Hokkaido also has crustal faults within the overriding plate where the smaller but still potentially damaging earthquakes occur. These are often related to local fault movements rather than the plate boundary itself. Usually classified as a moderate quake is a 5.0, often felt strongly near the epicenter but typically causes only minor structural damage. Depth and fault type affect the shaking intensity. Shallower quakes feel stronger on the surface. Due to its tectonic environment, Hokkaido experiences frequent earthquakes, including some large events capable of causing tsunamis. Earthquakes in the subduction zone can generate tsunamis, but moderate events like a 5.0 usually do not. Aftershocks frequently follow these earthquakes, which can last for days or weeks. So, this is our earthquake, which has occurred in Japan. And our next earthquake was a 5.0 in southern Iran. This one was 4 kilometers deep. I'm looking to see, this is the Persian Gulf here. So this is the Persian Gulf. This is the Gulf of Oman over here. This earthquake occurred today, 3:54 UTC time. A magnitude 5.0 earthquake struck approximately 28 kilometers southwest of Mor, Iran, in a southern part of the country. The earthquake had a shallow depth of about 10 kilometers and occurred at the coordinate, and I got the coordinates in here, but I don't need them because I already have them on the thing. Despite its moderate magnitude, the earthquake was felt by at least one person, but there were no reports of significant damage or casualties, and no tsunami was triggered. This region has experienced several seismic events in recent months. For instance, on January 6, 2025, a magnitude 5.4 earthquake occurred in the Jam area of Bushehr province, which was felt by approximately 164,300 people. Additionally, on December 21st, 2024, magnitude 5.0 earthquake struck near Bandar, Lenga, and Hormozgan province, affecting around 68,100 people. Given the region's susceptibility to seismic activity, it's important for residents and visitors to stay informed about local emergency procedures and be prepared for potential aftershocks. This area is geologically related about the 5.0 earthquake in southern Iran. Southern Iran lies within a very tectonically active region because it sits near the convergence zone where the Arabian Plate is colliding with the Eurasian Plate. This collision is responsible for the formation of the Zagros Mountains and generates frequent activities. The Arabian Plate moves roughly northward, pushing against the Eurasian Plate, causing crustal shortening, folding, and faulting. There is a major fault zone extending across southern Iran. Earthquakes there commonly result from reverse thrust faulting due to the compressional forces of the plate collision. Earthquakes in this region often occur at shallow depths, typical of crustal faults accommodating the collision stresses. Predominantly thrust and reverse faults aligned roughly northwest and southeast, but strike slip faulting can also occur in some areas due to complex regional stresses. A magnitude 5.0 quake is moderate and usually reflects rupture of a relatively small fault patch in the upper crust. While not typically devastating, these quakes highlight the ongoing tectonic strain accumulation in the area. This earthquake is part of a tectonic, it's an active tectonic environment driven by the Eurasian-Arabian collision zone. Continuous seismic monitoring and geological studies are crucial in southern Iran to understand fault behaviors and assess risks. So if we look here, we can see this is Eurasian-Arabian Plate. And then you have the same plate. This is convergent down here. And as we go up, well, we can come down over here. We can look and see that there is the Indian-Arabian Plate here. Then you have the Eurasian-Indian convergent boundary here. There's a lot of activity going on around this area, which is a reason for the earthquakes that occur. So, this was our 5.0 in southern Iran. Our next earthquake is a 5.1 off the east coast of Kamchatka. Let me drink some more water real quick and check the chat. Welcome in, everybody. Okay, this earthquake is occurring off the east coast of Kamchatka. And it occurred on July 28, 2025 at 11:45:06 UTC. That would be 10:45 p.m. local time. The epicenter was located approximately 138 kilometers east-southeast of Petropavlovsk, Kamchatka, Russia. The shaking intensity for this earthquake was felt in the region, but no significant damage or casualties have been reported. There have been no reports of tsunami threats associated with this earthquake. Now, if we're looking at this earthquake, this is more than likely an aftershock. However, I decided to go ahead and go over it because of the fact that July 20th, 2025, a magnitude 7.4 earthquake occurred off the east coast of Kamchatka, which triggered a tsunami warning that was later canceled. On July 22nd, 2025, a magnitude 6.3 earthquake struck the same region. On July 24th, 2025, a magnitude 6.1 earthquake was recorded off the east coast of Kamchatka as well. These events highlight the ongoing seismic activity in the region, which is situated along the Pacific Ring of Fire, an area known for frequent earthquakes and volcanic eruptions. The Kamchatka Peninsula lies along the Pacific Ring of Fire, one of the most seismically and volcanically active regions in the world. It is a convergent plate boundary where the Pacific plate is subducting beneath the North American plate. The subduction zone runs offshore along the eastern edge of Kamchatka, creating intense seismic activity including earthquakes and volcanic eruptions. The Pacific plate moves northeast and dives beneath Kamchatka at a rate of roughly 8 to 10 centimeters per year. The subduction causes stress to build up along the plate interface, often released suddenly as earthquakes. The region experiences megathrust earthquakes, smaller shallow earthquakes, and intermediate to deep focus earthquakes along the subduction slab. The 5.1 magnitude earthquake is typical of the active seismicity generated by this ongoing plate interaction. Kamchatka hosts numerous volcanoes, over 30 active ones, related to the subduction process. Magma generated by the melting of the subducted slab rises to form volcanoes, contributing to the region's volcanic activity. The area is part of the Kamchatka Volcanic Arc, which extends along the East Peninsula. So it extends along the Eastern Peninsula. So if you look here, this is the eastern side over here, and this is the volcanic arc here. The eastern coast is largely rugged with steep underwater slopes due to tectonic uplift and volcanic activity. The offshore area consists of complex bathymetry, including deep trenches formed by the subduction zone known as Kamchatka Trench. And this is Kamchatka Trench here. Sediments carried by rivers and coastal erosion cover parts of the continental shelf. The earthquake is a direct consequence of ongoing Pacific plate subduction beneath Kamchatka. The region's geology is shaped by dynamic tectonic forces, creating frequent earthquakes and volcanic eruptions. The Kamchatka Trench offshore marks the boundary where earthquakes likely originated. So, this is about our Kamchatka earthquake. Started off with that 6.1, then 7.4, and then lots and lots of aftershocks since then. Our next earthquake was a 5.1 lake, and I'm going to try to not to butcher this name. Tanganyika region, Congo, 10 kilometers deep. Now if we drop back, we're going to look here and we're going to see that we have the East African Rift System or divergent boundary here. So, this earthquake struck the Lake Tanganyika region near Uvira, south of Kivu Province, Democratic Republic of the Congo, on Monday, July 28th of 2025 at 13:38 UTC or 15:38 local time, which would have been, I believe, 338. Let me see. 12, 13, 14, 15. 4. I believe it was 438. There are no confirmed reports of significant damage or casualties. The earthquake was felt in nearby regions, including parts of Burundi and Rwanda. Given the magnitude and its location, it's possible the quake was felt over a wide area, but no major impacts have been reported. These events serve as a reminder of seismic activity in the East African Rift region, where tectonic movement can lead to earthquakes. The 2005 Lake Tanganyika earthquake, for example, had a magnitude of 6.8 and caused significant damage and casualties in the region. The geology around this area in the Congo is fascinating and complex because it lies within the East African Rift System, one of the most active tectonic regions on Earth. The East African Rift System, Lake Tanganyika, is part of the western branch of the East African Rift System. This is the continental rift zone where the African plate is slowly splitting into two separate plates, the Nubian plate to the west and the Somali plate to the east. This rifting causes frequent seismic and volcanic activity. The lake itself is a deep rift valley, and you can see the lake here. Formed as the Earth's crust stretches and thins, Lake Tanganyika, I'm sorry, I'm probably saying this name wrong, is one of the deepest freshwater lakes in the world, with depths reaching over 1,400 meters or 4,600 feet. Its formation is closely linked to the tectonic extension and faulting in the region. In this area, the dominant fault types in the area are normal faults, caused by extension of the crust. These faults allow blocks of crust to drop down, forming the Deep Rift Valley and Lake Basin. Earthquakes in the region, like the recent 5.1 event which we are discussing, are associated with movement along these faults. Seismicity is generally moderate, but can be strong with occasional larger quakes linked to adjustment in the rift. The bedrock beneath the rift consistently, mainly, and I need some water, of Precambrian, metamorphic, and igneous rocks such as gneiss and granites. The Rift Valley and lake are filled with thick sequences of sediments, including lake deposits, which hold important paleoenvironmental records. The East African Rift has many volcanic centers, though around Lake Tanganyika itself, volcanic activity is less pronounced compared to other parts of the rift, like the Virunga Mountains farther to the north. Where are the Virunga Mountains? Let's see, probably over here. I believe this is the Virunga Mountains, or could be over here. Well, it's one of these sides. It says to the north, so I believe it's these here. That's Virunga. Yep, I'm right. Virunga is right here. The Lake Tanganyika regional geology is shaped by active rifting process that pulls the African continent apart. This causes normal faulting, earthquakes, and formation of deep lakes like Tanganyika. The tectonic activity makes the area prone to seismic events such as the recent 5.1 magnitude earthquake. Okay, so now we're going to take a look. I'm going to check the earthquakes real quick. Make sure we haven't had anything else that's come up. And as you know, the last earthquake was the first earthquake that I talked about. So our next look is going to be Oregon Live earthquake map. And that is because we do have an earthquake over here towards the East Coast that I want to discuss. And this is over here in Tennessee. This one occurred yesterday. It was a 2.2. And it was 11 kilometers east-southeast of Mascot, Tennessee. This occurred yesterday at approximately 12:16 a.m. The epicenter was located about 11 kilometers southeast of Mascot within the eastern Tennessee seismic zone. This region is known for frequent small to moderate earthquakes and is one of the most active seismic zones in the eastern United States. Such minor earthquakes typically go unnoticed by the general public but are closely monitored by seismologists. The eastern Tennessee seismic zone has experienced several notable events in recent years, including a 4.1 magnitude earthquake near Greenback, Tennessee on May 10, 2025, which was felt as far away as Atlanta, Georgia. For real-time updates and more information about this activity in Tennessee, you can visit the University of Memphis Center for Earthquake Research and Information. Additionally, the U.S. Geological Survey provides comprehensive data and resources related to earthquakes. And as you can see, I'm mentioning that because we are using a site which uses U.S. Geological Survey for earthquakes. However, I am still watching over here in Virginia, West Virginia, for earthquake activity. Now, something else about this area is this area's most seismic zone in the eastern United States, stretching from northeastern Alabama through eastern Tennessee to southwestern Virginia. It is characterized by numerous small to moderate earthquakes. The seismicity is believed to be related to ancient faults that are being reactivated by present-day stresses on the Earth's crust. The region is part of the Appalachian Mountains geological province. It mainly consists of metamorphic rocks such as schist, gneiss, and quartzite. Sedimentary rocks like limestone and sandstone are also present in surrounding areas. These rocks were formed hundreds of millions of years ago during the Paleozoic era through mountain building events. This area contains numerous small hidden faults rather than a few large, well-defined ones. Many faults are ancient, dating back to when the Appalachian Mountains were formed. Present-day tectonic stresses cause slip or movement along the old faults, generating earthquakes. Unlike plate boundary earthquakes, which happen on the west coast, these quakes happen within the interior of the North American plate. Earthquakes in this region tend to be moderate to small in magnitude. The area's crust is older and colder compared to active plate boundaries, so earthquakes release energy differently. Because of the older, more rigid crust, seismic waves can travel further, sometimes felt over large distances. Mascot is near Knoxville, Tennessee, and is located in the Valley and Ridge province of the Appalachians. Many areas, let me see here. This area features fold and faulted sedimentary rock, mostly limestone and sandstone. The region's landscape include ridges and valleys formed by folding and faulting. The seismic activity reflects reactivation of these geological structures. This earthquake most likely occurred on one of the many reactivated faults within the Appalachian geology of the eastern zone. The complex history of mountain building and faulting, combined with ongoing tectonic stresses, leads to the frequent small earthquakes seen in this area. So, how many of y'all knew that there was also a 0.8 earthquake in New York? That y'all didn't. So we're going to go take a look at my favorite last site in our Canada. So as we look at this site, we can see that there has been quite a few earthquakes. Like on the 26th, I was making fun and saying that the earthquakes went to sleep. So as we can look and see, they didn't go to sleep on the 26th or the 25th. However, the bigger earthquakes that I have been wanting to look at occurred as a 4.1, 36 kilometers south of Grand Prairie, and a 0.8, 36 kilometers northeast of Buffalo, New York. So what we're going to look at is the 0.8 real quick, and I'm going to put this into Google Earth. And this is a very small quake, you guys. It's called a microquake. Usually earthquakes under magnitude 2.0 are not felt by people. You can see that this looks like a farming type area out here. Not see anything unusual. However, this earthquake was 36 kilometers northeast of Buffalo, New York, so roughly in western New York State, near the city, but still some distance away. Typically, shallow quakes less than 70 kilometers deep are more noticeable, but don't have any exact depth. At this magnitude, there's essentially no damage, and it's unlikely anyone felt it unless they were very close and sensitive vibration. Earthquakes happen because of movement along faults in the Earth's crust. Now, the geology here is the bedrock beneath Buffalo mainly consists of sedimentary rock from the late Ordovician to Denovian periods. That's roughly 360 to 450 million years ago, well before any of us were alive. Common rocks include shale, sandstone, limestone, and dolomite. Dolostone. Sorry, I want to say dolomite. These sedimentary layers were deposited in ancient shallow seas that covered the region hundreds of millions of years ago. Buffalo lies within an area heavily shaped by the last ice age glaciers, which retreated about 10,000 to 12,000 years ago. The glaciers carved out the Great Lakes and left behind glacial till, outwash plains, and moraines. These glacial deposits cover much of the bedrock, including influencing the soil and surface geology. Western New York is far from active plate boundaries, so it's considered stable continental interior. Earthquakes here are relatively rare and usually low magnitude, caused by intraplate stress within the North American plate itself. These stresses may reactivate old faults or fractures in the bedrock, but the faults are generally ancient and not very active. The region occasionally experiences small earthquakes, typically less than magnitude 3. Larger quakes are very rare, but small ones can occur due to reactivation of ancient faults. The seismic hazard is low compared to the West Coast, but not zero. The Niagara Escarpment, a prominent limestone ridge famous for Niagara Falls, lies just south of Buffalo. This escarpment represents a sharp geological boundary and is a key feature formed by erosion-resistant rock layers. So, Buffalo sits on old sedimentary rock shaped by ancient seas and glaciation. Is geologically stable area with low seismic activity. The small earthquake is typical of minor intraplate earthquake occasionally felt in the region. And I just got lost. Okay, so our next earthquake that we're going to talk about is, let me shut this one. I just lost Canada. Where are you, Canada? There you go. Our next earthquake we're going to talk about is this 4.1 in Canada. And if you can look, I believe this one is hit. Nope, that's not it. I was clicking on it earlier. That's 4.2. However, I believe that is it there. No, it was on the 27th. Well, anyway, I've got the link for it, so we're just going to go look at it on Google Earth. Because I clicked on it earlier and I was exploring it. So I will draw back here so that y'all can see where it is located in Canada. It is over here. And this is Alberta, Canada. All right, so it was actually listed as a 4.2 earthquake, and it occurred on the evening of Saturday, July 26, 2025, approximately 36 kilometers south of Grande Prairie, Alberta. The tremor was felt lightly in the city and surrounding areas, but no damage was reported. Earthquakes Canada has indicated that the quake may be industry related, possibly linked to activities such as hydraulic fracturing or wastewater disposal, which have been associated with induced seismicity in the area. So that was something that is not listed on here. So if we look, cannot see anywhere that it says industry related. So I find this interesting when I was doing my research to learn more about this earthquake. Oops, just got lost. Okay, so anyways, the Alberta Energy Regulator has also noted that the earthquake measured a magnitude of 4.04 and is under review to determine its cause. According to Earthquakes Canada magnitude scale, quakes between 3.5 and 5.4 are often felt but rarely cause damage. Approximately 70,000 people reside in Grande Prairie, located 458 kilometers northwest of Edmonton. Grande Prairie lies within the Western Canadian Sedimentary Basin, one of the largest sedimentary basins in the world. The region is underlain primarily by sedimentary rock deposited by Paleozoic through the Mesozoic eras, including limestone, shale, sandstone, and coal seams. The sedimentary layers are relatively flat-lying but can't be disrupted by faults and folds. The area is influenced by subtle fault zones and fractures that can serve as pathways for fluid movement. Some faults are ancient and formed during past tectonic events such as Laramide orogeny, and that means mountain building event 70 to 40 million years ago. Naturally, Alberta is low seismicity region, but human activities have increased seismic activity in the areas. Activities such as hydraulic fracturing, which is fracking, wastewater disposal, and other oil and gas extrapolation techniques have induced earthquakes here. These induced earthquakes typically occur along pre-existing faults that are reactivated by changes in underground pressure. The area around Grande Prairie is rich in oil and natural gas, with several producing formations. Hydrocarbon extraction plays a major role in the local economy, but can be linked to seismic activity. The surface is mainly covered by glacial deposits from the last ice age, which left till, sand, and gravel. The topsoil and subsurface geology influence groundwater flow and local land use. So, what we're learning from all of this is being prepared for earthquakes is crucial because they can strike without warning and cause serious damage. Preparation starts with knowing the safest places in your home or workplace, like under sturdy furniture or against interior walls. Secure heavy items and appliances to prevent injury during shaking. Create a communication plan with your family or co-workers so everyone knows how to check in after an earthquake. Keep an emergency kit stocked with water, non-perishable food, flashlights, batteries, and first aid kit, and important documents. Regularly practice earthquake drills to build confidence and ensure everyone around you knows how to drop, cover, and hold on. Staying informed about local earthquake risks and safety recommendations can save lives and reduce panic when the ground moves. Being prepared helps you to protect yourself, your loved ones, and your property, and to get through when an earthquake strikes. So you guys, that's all I have for earthquakes so far. Now I'm going to take a look at the weather. And we'll see what's going on for the tropics. So we can take a look out here. I'm hearing people saying there's stuff going on over here, stuff going on over here. Well, there is stuff going on, but they're just not showing it right now. However, if we look at the Eastern Pacific, it's pretty busy out there. We got 4 little systems going on. 4 at a time. So let's see here. This one has a 90% chance in the next 7 days and a 60% chance in the next 48 hours. Then right here we have one that has a 60% chance of cyclone formation in 7 days and 60% in the next 48 hours. Looks like those odds are about even. Then we have Tropical Depression 2, and it is moving along at 11 knots, 13 miles per hour, with winds as high as 35 miles per hour. Then we have Hurricane Iona, and Iona has 10 mile an hour winds and 75 mile an hour winds. It's moving at 10 miles an hour. So that's what we have for out there. Anyways, you guys, I hope y'all are doing well today. Just wanted to drop in, give y'all an update. I'm glad that y'all were here. I appreciate your time. Thank you for watching. And I will be live probably tomorrow around the same time. And hopefully we have more interesting topics. Anyways, you guys, I love you. Richard, thank you for being here. Brooke Fishing, thank you for being here. Kathy Berryman, thank you for being here. If anybody has any questions, please put them in the chat and I'll try to answer them. Kathy Berryman, what it is, and it's what I understand about the downgrading of earthquakes, is because they use different sensors. And the closer a sensor sits, the higher it's going to be. The further away it sits, the lower it's going to be. So they try to go with the most accurate. So sometimes the most accurate one will show that it's actually lesser. Anyways, you guys, I love you. Please remember to tell someone you love them. Tomorrow is never promised. And make each day an adventure. Much love, and I will see you all on the next live stream or the next video, whichever one comes first. Whoa! Twin earthquakes, huh? There was a 1.9, 5 kilometers east of Marston, Missouri, and a 1.8 northwest of Ridgely, Tennessee. Thank you, Cece. I appreciate it. Thank you for being here. Nice to see you guys. Anyways, you guys, I will see y'all on the next video or live stream. I am losing my voice right now, and, I don't know why. But I love you. Please remember to tell someone you love them. Tomorrow's never promised. And make each day an adventure. Much love, you guys.